Hello, everyone, and welcome to today's webcast with Densify and Red Hat. My name is Chuck Tatham. I'm the Chief Marketing Officer and VP of Business Development at Densify, and I'm your host today. I'm the guy in the middle, if you can't tell. I have with me today Dinesh Ravindran, who's going to be covering the technical and demo portion of our presentation. And we're also really pleased to have Kevin Holmes here, solution architect at Red Hat, and also the owner of the very coolest home backdrop, which a bunch of 3D printers in his back. So I just wanted to call out, he's actually been repurposing these devices of late, from printing baby Yodas to now actually helping with COVID. With more serious things, face masks, and show the shield. It's really quite cool. So very innovative use of these great devices. But on to other matters. This is the first webcast in my career where I think I can safely say most people are viewing from home, which is kind of cool. We three are, and I assume all of our audience are. This session was of great interest, I think, not because people are at home, but because container management technologies like OpenShift, Ansible, and analytics like Densify are an interesting combination. And so our agenda today is pretty simple. I just got to wait for the slide to advance here. We're gonna talk about the Densify Analytics engine. We're going to talk a little bit about some of the emerging resource management challenges with container infrastructure, how analytics can help you meet those challenges, and then we're going to tie it all together by bringing these Red Hat and Densify technologies together and talk about it in the context of DevOps processes and DevOps tool chains and the way infrastructure is being managed increasingly today. Dinesh will actually demo some of this automation, which is pretty cool. And then we'll cover on how you can get more information and engage further if you like. And from a Q&A perspective, if you have questions throughout the presentation, you'll see there's a questions console or a questions area of the GoToWebinar console. You can log those questions, and we will endeavor to answer them toward the end. If for whatever reason we run out of time, we will reach out and answer questions that don't get answered in the event that occurs. So that's our agenda. I'm going to dive right in and just introduce you to what Densify is. This is enterprise class resource management optimization and control that can be applied to a public cloud, container, and private cloud or VMware infrastructure. This is a single technology that allows you to address in the same way, with the same sophistication across all these infrastructure types. In the case of virtual infrastructure, we are a patented engine and capability for determining optimal and compliant VM placement, for managing capacity, driving density safely, and as a byproduct, a big area of savings these days for companies is through optimal placement, saving in per processor software license dollars. These are the main reasons Densify gets deployed into a VMware infrastructure. From a public cloud point of view, cost, ever present, improving purchasing, automating capacity optimization. A lot of what Dinesh shows you here can be applied to not only containers, but public cloud and virtual infrastructure. And then from a container perspective, general observability, controllability, which is our take on how you take what you know about what should happen in a container infrastructure and apply it back to active management and automated management. And two key themes you will see across public cloud, containers, well, actually all three of these, is we place a lot of emphasis on the importance of communicating what you're going to do to infrastructure from an optimization perspective down to the app owner, and collaborating with the owners of the business applications in the enterprise to make sure that everyone is on board. Our customer base is aligns with that enterprise scale. Our customers are the biggest organizations in the world. We've been doing this kind of optimization for years in many recognized brands. So from an infrastructure management realities perspective, we center ourselves with this technology around the reality that large enterprises are going to be hybrid now over the long term, and will have to handle likely all three of these infrastructure types. The management stacks being brought to bear in controlling these kinds of environments, provisioning and orchestrating the new school, are really technologies like OpenShift and Ansible and as code frameworks versus anything out of the box in a cloud management platform, kind of the old way of thinking about it. And that in almost every case, and especially today, financial concerns with respect to cloud and emerging container environment complexity are a major challenge. So why is resource management critical in this kind of flow? The reality is that if you look at any chain of deployment or delivery or DevOps or just infrastructure management in general, there will be major categories of functionality, but the resource selection piece is largely being left to humans who are really guessing or estimating what the resource requirements are. And they're increasingly getting embedded in the code, in the infrastructure as code frameworks, which means they're perpetuated long-term. And if you think about it, in the days of a VM, and thinking about the resource requirements of a VM, not unlike thinking about, on my notebook, I need quad core with 8 gig of memory. People kind of understand that as a body of capacity or contiguous capacity. When you jump to container resource management, think about it almost like your task list or process list on your machine. And think about PowerPoint. How many millicores does PowerPoint need? Said no one really ever. And if you look at the decomposed resource and processes, nobody really has a sense for what any individual element actually needs. And so, if we look at it in the context of embedding those resource requests and limits and leaving it to humans, it's a big potential problem. Because if you take those humans and they go into a container environment, and at the process or container level, they specify their desires, the scheduler has to honor those, and we use a Tetris block as a stunt double for a workload here, the dotted line being the resource. The scheduler has to honor that. And it will start as many nodes as are required in order to do what has been asked of it. And everywhere we go, every environment at scale, a container environment we audit, we see this dynamic where the aggregate, and this is a real trace of aggregate CPU reservation from I think it's a large retailer over a couple months. The CPU reservation is wildly different than the actual utilization. And the utilization, when compared to the reservation, leaves a lot to be desired with respect to excess capacity deployed. And in most cases, and we'll talk more about it, we see customers can actually do with about 50% of what's provisioned. And that's a pretty powerful statement, again, especially not to belabor this current cost-sensitive world, but it's pretty important. Now, the other side of this is the potential for human error-driven risk. This was one that was found in a real customer environment with a case-sensitive issue on that M, causing a limit to be set to 300, I guess that's billion millicores. That's a problem in its own right, not wasteful, but potentially can create a whole lot of issues in an infrastructure. So the whole point of that is to say you don't have to leave it to humans to do this, that there are ways of doing this in a more scientific fashion. We call it cloud learning optimization engine, or CLOE. And what the core of Densify does is constantly learn from the behavioral patterns of the workloads down to the container level, the VM level, the cloud instance level, whatever it may be. The more time we watch, the better our predictive models become. We cross that with constantly updated information about the realities of where you're running, the performance characteristics, the technical rules, the constraints, everything from on-prem bare metal to in the cloud. It doesn't matter. We're constantly ingesting those specifics, and that allows us to normalize everything and feed our analytics with it. We have the ability to do rich tagging so that you can associate other important elements with your workloads down to the VM or container level. And then we have a policy engine, and the policy engine allows you to codify what is fit for purpose for any given component or workload or business service. And that basically says to CLOE, hey, here's how we want to run. Here's the, how we want to run dev test. Here's how we want to run production critical, market facing, whatever it is. And what comes out of the engine then are constant, precise resource specifications. And these are around resource allocations. So how much should I give the workload? How much white space should I save for it? How conservative or aggressive am I going to be? What are the placements that are going to be properly aligned with my governance rules or my efficiency targets, my overcommit aggressiveness? That playing that better game of Tetris. I want to move something, maybe let's say on-prem VMware to in the cloud on containers as an example. What would I provision in order to do that? And then the fourth thing is most important in the cloud. How do I then make sure I'm buying everything appropriately? How do I know that I'm optimizing the way I'm purchasing? You can't optimize the way you're purchasing unless it's tied to the actual true consumption requirements. These answers can go in a variety of directions. For many people with containers, just the observability, visibility, and understanding what's happening down to the container level is extremely powerful. But at some point, you want to start actioning. You might want to get the recommendations and the actions through to a ticketing system. We now have the ability to deliver recommendations right down through a collaboration environment like Slack to the app owner to say, hey, you subscribe to your app, here's a change we're suggesting, can you let it happen? And then at some point, you want to drive it through to the orchestration or the execution side. And our most advanced customers are embedding this in really the fabric or the as code for the way they manage, just make it part of the life cycle. And that's what we'll be showing you as part of this. The whole point of having a central point of truth. So not just a tool that's helping finance, but an engine that is first and foremost assuring that applications are happy so that app owners and engineering and ops get what they need. And then and only then is it done at the right cost. And if it's all tied to the actual science of the true consumption of resource by the applications, this is a perfect world. Birds are chirping, everyone's happy because the bills are as low as they should be because it's scientifically aligned. So if you see how this surfaces, our demo is actually going to be less about UI, more about how we connect the intelligence to the action. This is typical of a dashboard that shows me overall the savings or optimization that is lurking, the potential. I can look at the high level of my container infrastructure, my clusters, my namespaces, my pods. I can look at my summary of optimization opportunities and what the impact would be. Great for sort of surfacing at a high level. The magic of Densify though is down into the detail. So now I'm drilling in on a deployment here, and I'm seeing that some recommendations are being made. And if we zero in on the actual workload, we can see here that for some reason, someone has set requests and limits at the same value. That's why this line is dotted here. Densify has determined what the actual limits and requests should be to properly service the peaks, but drive a level of overcommit that is responsible based on sustained activity. As we go to play that game of Tetris, things are serviced properly and provisioned properly. And in aggregate, if we were to take all these changes, we'll see that we're going to give some more resource from a memory perspective and take back some from a CPU point of view. And the aggregate impact in this particular environment was about 20% and 15% on both those resource types. So if we have the detail of these answers, what the opportunity becomes is starting to pair those answers and going from just being aware of what's going on and having the observability and tying it to great technologies such as OpenShift and Ansible. So Kevin, why don't you introduce those two components here quickly?
Absolutely. So 1,000-foot view, OpenShift container platform is the place to both use as a service catalog for your containerization, observation, and management of those resources. However, along with that, the additional technology, Ansible. Ansible is the mantra has always been simple, powerful, agentless. The Ansible component to this gives a prescriptive or desired state. So effectively, you could say, I want to do X, Y, and Z with these parameters, and through an agentless method, Ansible is able to apply those changes to the end result. So that's sort of the overview. As deeper questions arise, I'll be around as well to help answer any questions.
Thanks, Kevin. So with that, let's pass to Dinesh, and he'll take us through how these things are deployed together, how they interact, and make this an embedded or systemic part of the way containers are managed. Dinesh? Can't hear you, Dinesh.
Sorry about that.
Perfect. There we go.
Up until now, we've seen some of the use cases that Densify supports and how we generate some of those recommendations in the form of insights. For the remainder of this webinar, we're going to talk about how do we take those insights and make them inject them into the environment such that they affect change in the target venue to an automation technology like Ansible. And this process we call continuous optimization. Okay. So before we get to how, specifically what is continuous optimization, how do we include it in the DevOps pipeline, I'm going to go back to this one slide, which really articulates the problem statement, and we'll look at it from the perspective of OpenShift. The top right-hand corner, you're seeing the actual problem. The resource allocations are being persistently hard-coded into the container manifest, which is resulting in a suboptimal allocation of resources down at the container level. As Chuck mentioned, Kubernetes or OpenShift would have to honor whatever specification is being provided through those manifests. So we're looking to solve this problem. From a high level, what are some of the requirements that we would want to see to really drive a solution? The first and foremost, and the obvious one is, I don't want to have to guess what those resource allocations are, because honestly, as a human, there's no way for me to scientifically derive the appropriate resource allocations for all of the different containers running in my environment continuously. And the second really being is, my CI/CD pipeline is already complicated. It contains a vast number of various different applications in that ecosystem. I don't want to introduce another tool that I have to manage to drive this optimization. Can I do without it? So that's what we're going to try to aim for. So first and foremost, we start with that container optimization. We need some technology to extract those resource utilization metrics, configuration metadata to produce the insights, to infer what those insights are. I'm already, some of you are already thinking, well, that's a tool that you're going to introduce into this particular ecosystem. Well, yes and no. Densify can actually be implemented into a DevOps ecosystem, and you wouldn't have to manage it after that initial configuration point. It completely operates behind the scenes. So from an interactability perspective, you'll be interacting with it through other DevOps tools that are already existing in your pipeline, and it would automatically talk to deployment technologies that would manage the infrastructure. And we'll see how that works as we continue through this. So once we have these insights, we need a way of somehow magically inserting them into that target menu. So wouldn't it be nice if I can update those resource specifications in the manifest to say, instead of having hard-coded values, to say, can I look these values up from a third-party source? And can Ansible inject those values into those manifests? Okay, so if this is possible, then what would happen is Kubernetes will automatically adjust the resource allocations for those underlying containers, and its bin packing algorithm will automatically constrain those particular applications to the minimum number of worker nodes, thereby reducing the overall estate requirements. And at some point in the future, we can come back and say, can I optimize the underlying worker nodes itself? And in this case, we're optimizing that on a second level of analysis. Okay, the problem statement. Now, before we get to the DevOps again, I want us to talk about how we're actually getting those answers into the target estate. How is that magic actually happening? Okay, so let's look at the state of the world as it is today. If someone is managing an OpenShift environment through Ansible, you would have a platform owner that would deploy an OpenShift environment through some means. Ansible works by operating from what they call a control node. It could be a VM. So this could be external from OpenShift or inside. So we have this control node, we deploy Ansible on it, and Ansible would require a playbook to execute whatever changes it need to execute. In this case, we're using Ansible to manage the underlying containers running on OpenShift. So we start by creating an Ansible playbook, and in this case, you can automatically see this is a sample playbook that talks about a container being deployed, and it's leveraging the KDES module. It's an out-of-the-box module that's used to manage Kubernetes objects in any target environment. The bottom of the template is the problematic area where we're actually seeing the resource specifications being hard-coded in. The alternative mode here is to not provide these resource specifications. And the resultant behavior in that particular path of execution is Kubernetes, the default behavior would be to allow that container to grow to the maximum limits, the resource limits of that specific worker node, which is why it's a best practice to always specify what those resource specifications are in the template. So if we were to execute this playbook, Ansible would deploy it through OpenShift, and you would see that container being deployed, and you can see in this particular graphic, there's some excess space. We're trying to depict that there's some wasted resources being allocated to this, creating a state of wasted resources. Okay, so we go back and take the same picture, and we're saying, okay, is there a way for us to optimize this container running in this target environment? We start with the same template. We focus back in on that problematic area, and we're saying, can we do better? Instead of hard coding these values in, is there some capability within Ansible that we can leverage to now inject recommendations in line? One of the neat things about Ansible is that it's a very extensible technology, meaning that I can develop pieces of code, custom code, and have it execute as a separate module within Ansible, or as a function that provides data input to any existing modules. And that's the capability that I'm actually interested in. They're called lookup plugins, and these lookup plugins can extract information from third-party systems and deliver that insight in line directly into a module. So if I were to upgrade or modify this playbook, this is what it would look like with a lookup function. So for those resource specifications, instead of hard-coded values, I'm saying go out and pull me the optimal values from any external repository, So in this case, let's take a look at some of the inputs into that lookup function. We're saying, we're giving the function we're telling the function what we're trying to look up. Is it CPU? Is it memory? Is it a limit? Is it a request? A default value, you have to imagine that if it's a brand new container, there wouldn't be an optimal recommendation. We wouldn't know what it is. We need a starting point. So that's what the default specifies. Identifier, there's a ton of containers. Which container are you talking about? Okay, and this last piece here is the parameter repository. And the parameter repository really comes from best practice around how you manage configuration management technologies or infrastructure as code, where you have variables within the template that can potentially change in the future. Best practice is to really surface those variables out of the template. You parameterize them, you surface them out of the template, and you manage them in an external repository. so that in the future, if those parameters were to change, there wouldn't be any source impact of the templates. You would modify the parameters as they exist in the repository, which provides traceability, auditability, and of course, source control. And then of course, when you just have to re-execute that template and it would reference the values immediately. Okay, now if we were to re-execute this playbook, then what would happen? You could see that in the target venue, that container, the resource allocation is automatically being sized optimally by OpenShift. It's honoring whatever is being returned in those lookup functions. Okay. Now the DevOps pipeline. A lot of you guys have seen, a variant of the DevOps pipeline. It's also referred to as the CI/CD pipeline. It's a series of processes such that when integrated in a specific sequence, it allows you to get a piece of code from source to production automatically. And there's various different processes that help you execute that process. So, for example, we have plan and coding phases that allow developers to commit new code to the entire product, build processes to build that piece of code back into the product, testing capability to test that code automatically or test that product as a whole, release and deployment technologies, getting this product deployed into a target venue, whether it's allocating resources or infrastructure or even deploying that application onto that infrastructure. Operations and monitoring code to actually look at how that application is behaving, not just at the application level, but also at the infrastructure level. As you guys can imagine, the infrastructure monitoring is really what we're interested in, because if you remember the first part of the webinar, we're really going to take that infrastructure utilization or how infrastructure is behaving to infer the performance of that application, to come up with sizing specifications, say, listen, the amount of infrastructure we need is blah for this specific application to allow it to run at its most optimal performance level. Okay, the sequential nature of this pipeline and the automatic integration and automation of it is referred to as continuous integration and continuous delivery. Now, because we're going to introduce the concept of continuous optimization, we need to somehow integrate back into this pipeline, and we need to be cognizant of how complex that ecosystem can be. It's made up of various different tools, different combinations, different customers, different organizations use different combinations of these tools. So whatever enhancements that however we extend this particular DevOps pipeline, we need to be cognizant that the solution that we provide needs to be able to integrate into the specific process technologies that we need to integrate into. So let's talk about how we extend that pipeline to include now continuous optimization. So from our experience, we know that we need to introduce some additional processes. It cannot be an integration. It cannot be any loops within the existing processes that we already have. So the first piece here is we need to infer insights from the monitored resource utilization. So data that's coming out of the monitored phase, it's in a raw format. I can't just take that and say, based on this raw utilization statistics over X period of time, you need to size the specific application to blah. We need to really analyze that in depth to infer what that insight is. So we need to introduce an analyze phase to help us with that. Additionally, from experience, we know that resource allocations cannot just be implemented continuously without some type of authorization or approval from the organization. So this is where we need to introduce some type of collaboration phase where we can collaborate with the owners of those applications to say, listen, this is all of the scientific evidence behind why we believe it should be sized, this application or infrastructure should be sized to blah. Are you able to authorize and approve this? So with these are the two new processes that we need to introduce, but we also create a feedback loop because we have to inject these recommendations back in the CD process. So we know that we're integrating back into existing processes. So what are those two existing processes? Deploy and monitor. And this integration back, we call this continuous optimization. Okay. Now I'm going to tie the whole picture together with this final architecture diagram, talking about what is our implementation for the Red Hat OpenShift? How do we see this running from an end-to-end perspective, continuous optimization? So we start with the top right left-hand corner here where we have the OpenShift environment. We are monitoring or collecting statistics over Prometheus within that environment. So Prometheus gets deployed as a container, and that's extracting also all the resource utilization metrics. Now, this data in itself is not enough for us to derive an answer. We need context. We need to know how to analyze that specific application. Is it production? Is it development? Is it testing? What is it? So this is where we allow those container owners to specify policies And policies, without getting into too much details, it allows you to configure different treatment paths for those applications. So we churn the data, we produce a set of recommendations or insights or inferred insights. But the next stage here is we have to go and get authorization. And we do this by injecting these insights through an approval acquisition process. And this is done by delivering the recommendations to an ITSM ticketing systems like Jira or ServiceNow, or even collaboration services like Slack or Microsoft Teams. Now, these are tools that are already sitting inside the DevOps pipeline. They will already be there. So we're re-leveraging technology that already exists. So up until now, an end user, like an application owner, wouldn't be directly interacting with Densify. Even for the management of the policies, once they're initially set, you wouldn't have to re-log in back to Densify.
So just a point on that, Dinesh, that we've learned over the last number of years on actually having the right answers is only step one to actually driving optimization. And ultimately, someone has to approve. And there can be a lot of resistance if there's a lack of trust or they don't think you have the right answers. And so those app owner reports that we send out are really designed to show our work, basically, and provide all the evidence for the reasons that these changes that are suggested are either going to make you perform better or make no difference because you've just got way too much reserved. And as a reasonable person, would you please allow these changes to happen? And if this happens,
the other way as well, it's not always about downsizing. If the application is at risk, we identify that risk and we may upsize certain resources to provide the performance that's needed.
Yeah, it comes back to, lots of times things get deployed, people forget about, keeping track of utilization levels. Maybe things get busier than they once ever thought they might be, and this works up and down, by the way. Yeah.
Okay. So with that, one of the additional value propositions here is because we're using an already existing technologies within the DevOps pipeline, there's a very short learning curve. So these application owners are already interacting with these systems today, and we're delivering those insights through those same systems. So the app owners can actually register their specific applications, which would allow them to receive alarms and notifications, as Chuck just mentioned, and ultimately provide approvals or denials of a specific insight for their specific application. Now, if Densify were to receive an approval, it's only then do we actually begin the process of continuous optimization or execution of that specific insight. And we do that by delivering that insight immediately into their parameter repository, which best practice would deem that parameter repository is already sitting inside the CI/CD pipeline. It's already pre-integrated into their CD processes. Okay, so if engineering were to deliver some new piece of code, it would automatically trigger the CI process that's already kicked off. And we're waiting for a trigger from that container platform owner to kick off the deployment processes. So if we receive that trigger from the platform owner, then the CD processes would kick off. And in this particular case, if the infrastructure deployment technology and code deployment technology is Ansible, then Ansible would pick up the updated values from the parameter repository and inject the change directly into that target menu. And if we can achieve this cohesive feedback loop between data collection, approval acquisition, and CI/CD, then we consider the entire environment to be in a continuously optimizing state. You would have achieved CO inside your DevOps pipeline. A lot of the organizations that we work with have always asked us the question, now this is great, but we want to be able to monitor this, to manage this from a management perspective. How do we know what the progression looks like over a period of time? Well, this is where we provide a parallel track of complete visibility through our reporting services. So across any period of time, we come out and we say, how has performance improved in that specific environment over the applications that we've influenced? How has cost improved over that same period of time? So complete reporting service arm is also provided as part of the solution. Now with that, I'm ready to get into a quick little demo. It's a very short demo to depict how we can inject these answers automatically through Ansible.
And as you queue that up, Dinesh, reminder, if anyone has questions through the console is the best way.
Okay. So this demo is going to be completely done through CLI. So we have two different VMs that are running in here. We have an Ansible control node, In the control node, we've already deployed Ansible as well as OC. OC is the OpenShift command line utility that helps us manage OpenShift environments. Okay. Now, there's also a VM here for OpenShift, and if anyone's wondering, it's a single VM, and it's done. We're able to do this because we've deployed Minishift on this particular VM, right? So it's a CentOS Linux kernel that's also running it. So on the Ansible control node, I'm already in the correct directory of my Ansible playbooks. I have two different playbooks here, an unoptimized playbook and an optimized playbook. So we're going to start by deploying an application. Actually, before we deploy the application, let me show you the environment. You can actually see it's a brand new environment. There's nothing running in it. There's only one project, my project. And if you were to deploy Minishift, this is the only namespace that would have been created in the environment. So even if we do OC get pods, you'll notice that nothing is running in that environment. So let's dive into the, actually, we don't need to actually log into it. So if we actually look at the contents of the unoptimized template, then this is what it's going to show. So what we're interested in is this particular set of lines of code, this module execution. So it's running on the KDS module. It's a deployment object, and it's deploying an application. Now, what application it is not really relevant to us. What I'm trying to show in this demo is there's some application. It's been deployed with some set of resources, and it's an unoptimized set of resources that it's being deployed with. Can I, in the future, come back and redeploy this application with a more optimal set of resources by leveraging the same template without any major changes? That's the purpose of the demo. So if we look at this particular application, it's a hello world application. But what we're really concerned with is this bottom section of the code, which is depicting the resource specifications for requests and limits. And you can see that we have some hard-coded values here, CPU and memory. Now, in case anyone's wondering, the lookup functions are specified in here as well. However, they're commented out, essentially meaning that Kubernetes and Ansible is going to ignore these lines of code. So over here, we're saying I want 300 millicores for CPU as the request, and the limit should be 600 millicores, and 64 megabytes for requests, and of course 128 megabytes for the limits for memory. Okay. So how do I run this playbook? So Ansible allows us to execute a playbook using this command here, playbook. And I pass in the specific playbook that I want. In this case, this is the unoptimized playbook that we just reviewed. If I were to run it, then we can see that it's going to go out. It's going to do some things here where it's going to go out and deploy that specific container. Okay. So if I now run OC get pods to see what pods are running in that environment, I can actually see one pod that's already running. Now, when I get some details behind what's running in that environment, I can do that by executing describe pods command, and we can see that the pod has been scheduled. It's executing in the environment. Its memory and limits for CPU and memory limits and requests that have been set are aligned to what's been specified in the unoptimized playbook. So Kubernetes OpenShift is actually honoring what was specified in the playbook or the container manifest. The question now is, so we have this container, it's running. Can I optimize this? So if I look at the optimized playbook, and it's the same playbook, I haven't made any change. I literally copied it over, and I modified these beforehand, so I wouldn't have to do this in VI in flight. So you can see what I've done here is I've just hashed out the hard-coded values, and I've unhashed the lookup function, saying that, listen, now I want you to go out and look up what the optimal values are for CPU and memory requests and limit. Okay. So from a user perspective, they're managing their environment using Ansible. They're just running an Ansible applied playbook every single time. And now all they've done is just modify these 4 values inside their template for this specific application. Now, if they were to run this again, what would be the value? In this case, it's saying go up and look up the value from an external source. Data deployment -optimize. This is a new template that we're running, the modified template. If we were to run it again, then Ansible is going to go out and it's going to try to remodify that template. So we see get pods. If we were to run OC get pods, we can see that container is running in the environment. If we were to take a look at what's running, the specific details behind it, if we OC get describe pods, we can actually see that same container However, the only difference now is the actual limits and requests for CPU and memory have been modified. So in this case, it's interesting to know what's been changed. So if you remember, CPU was originally running from 300 to 600 millicores. In this case, it looks like we've downsized it by 50 millicores. But look what's happened to memory. We've actually increased the memory requirements. Because in this particular case, we looked at that application and said, listen, you have too much resources for CPU, but not enough resources for memory. And this is where I was saying, this is not just about downsizing all of your resources, your entire state. It's also about, it's really about ensuring those applications are running at optimal performance. And in some cases, that means increased supply for a certain metric if needed. So in this case, we've doubled the amount of memory that's required because that's what's demanded by the application in order for it to run optimally. And we've reduced the amount of CPU because it's really not needed. We've looked at the utilization and it's just not using the CPU that it's been specified. Okay, so with that, that's it for the demo. And we have one or two more slides that.
Thanks, Dinesh, for that demo. So just to summarize, we've taken the normal behavior of hard coding and variabilized those resource settings and said, hey, get those from the brain in the case of Densify, and go from best guess to empirically derived. That's really the essence of what we've done. Now, as I said, our most advanced customers operate this way, and oftentimes people get excited about this potential, but they say, well, we're not quite ready for that yet. Well, if you want to get to that level of sophistication, there are very logical ways to go about that, and it starts with the basics of observability or visibility, which we would call phase one, which is just understanding the infrastructure. So you could drop a Densify instance in about 15 minutes, start connecting it to VMware infrastructure, container infrastructure, Prometheus, and AWS, Azure, or your cloud environment of choice. It's all agentless, and we begin to surface information so that the organization, the app owners are more informed. So we've done nothing other than make the organization smarter with respect to actual resource consumption. In the case of public cloud, this might give you the ability to just start tweaking your reserved purchases or your savings plans, those sorts of things. But at some point, you're going to go to actioning, and actioning in general would be starting to make some of these changes in a manual fashion. So actually going and changing resource specifications. Generally, we see this happening with, perhaps a more progressive set of stakeholders internally, maybe app owners or a business unit that are under the gun to actually, start to right-size things. But at some point, most people want to get to some form of closed-loop automation. And it's not just automation of the change, it's automation of the generation of the answer, the distribution of the answer, the approval of the suggestion, and then the embedding of the correct resources. And that's where we get to this notion of CI/CD, CO, or continuous optimization. The journey or the path is really to go from old school manual resource management, which is really born in the days of large hardware purchases and making sure you had enough on the floor, toward automated resource analytics and the management of the application of the right answers into the infrastructure. Now, some organizations go really quickly. Others, may only ever get to, let's say, manual actioning. But the point is to modernize the way you're doing this. As you go to cloud and you're more agile and provision stuff faster and iteratively, and you allow DevOps teams more autonomy to actually specify resourcing, you're effectively losing control or governance over this stuff. And so this represents the opportunity to reel it back in a way that is non-intrusive, but gives you that control. Our trials are free, and they range from 14 to 30 days. and literally we can stand up a dedicated instance for a customer because we're SaaS deployed in about 15 minutes. It's really that quick, and that's where our trials come into play. From a more information or trials perspective, and I'll throw out again the opportunity to ask questions. There are a few questions that we will address here, but if you'd like to reach to me, if you'd like to reach to Dinesh, we had a large number of IBMers register for this session. I wonder why. John DeFazio at Densify manages our relationship with IBM. That's a great point to reach to. From a Red Hat perspective, there's Kevin's, how you got Kev at redhat.com, I don't know, as a relatively new employee. Good going. And then our trials link, take us up on that offer. Very little downside. You don't pay anything, and we'll show you what's going on in the infrastructure according to that Chloe analytics engine. I will add that this presentation has been recorded and will be posted and emailed out to all attendees and registrants. And we do have a number of other webinars on different topics, but related topics listed up on our website should you be interested in more content like this. But just some questions. Dinesh, what if there are no existing optimal values known?
That's why we provide the default. You'll be able to specify what those defaults are, the startup values. That container would get deployed in the environment, and we would monitor the behavior of that resource utilization. And at a time,
so basically you're giving the developer their desires or the specifier their desires, and then when Densify has a better answer, has watched it long enough according to policy, because policy can say how long you need to watch before you can give a
so that lookup function that we're implementing, it will actually return the default if no better answer exists. And once a better answer exists, it'll start returning the optimal values or the optimal answer. That's it.
What about other data sources into the engine?
Absolutely. So parameter repository is a generic term. So this can be done with AWS Parameter Store, DynamoDB, various different technologies. So some of our customers,
Sorry, I think the question might relate to other performance or utilization data sources.
Performance. I suppose you're referring to the initial monitored statistics. So we do collect statistics directly from the environment, via direct API, or we can enrich that set of input through centralized monitoring tools as well. So if you have other monitored data that you want us to evaluate for inference or optimal recommendations, then we could also consider that.
There's a question on pricing, which I will return to. Someone asking if the playbooks for this can be shared.
Yes, it's not a problem.
Do you want to promote your the section of your the website, Dinesh? The developer section of the website, is that where they would go?
We are building some content that's coming out of this for that part of the website, so you guys will see some tutorials on how to set this up.
So there is a developer section up on the website where most of this technical content would be found. It's just recently launched and will get richer over the next few weeks. If you wanted to reach to Dinesh and ask more questions about that, just directly, feel free to use that email address. Dinesh, perspective on how long to get the basics of something like this set up, start to finish?
It's rather quick. So initially, if you have a Densify instance, then you can generate those optimal recommendation insights. By doing the appropriate configuration with Densify, which we can guide you with, we would start registering that optimal recommendations into some parameter repository, whatever you guys are using today. And you guys saw the changes I made to the Ansible playbook, right? It was just modification of 4 different lines, specifically the resource specifications. That would be it.
How would this be applied to VMware or infrastructure as a service or public cloud in general?
It's the same approach. So if you think about public cloud, it's just IaaS services that are running in that environment. So EC2, RDS, even ASGs. So we integrate into public cloud environments to collect statistics about those underlying resources as well. And we provide the same types of insights into the parameter repository of choice. And if you're managing your IaaS environment or your public cloud environment using some type of IAC tech like Terraform or CloudFormation, it's the same concept where we integrate those optimal insights directly in line in the code, so it's persistently available. For VMware, same type of idea as well. If you're managing VMware using IAC, then it would integrate in line as well.
Okay, the last appears to be the last question on how Densify is priced. Densify it's a SaaS product. It's an annual subscription. It is priced based on the scale of the infrastructure being watched over or optimized. We base it on the number of workload instances. So a VM is a count of one, and the larger the number, the lower the unit price per year of those instances are. Now, container environments can be more volatile and a little more numerous than VMs, and so we do have ratios that would apply to container environments, but it's all based on the scale. So it's not based on how much you're spending in the cloud or anything like that. It's based on the amount of stuff we're optimizing, for lack of a better description. And if there are no more questions, I think we wrapped up with 6 minutes to spare. Kevin, thanks for participating with us. It was great to have you.
Thanks for having me. Pleasure's mine.
Keep that printing going. Looks like potential great, not the Yoda, but the protective gear. That's probably a better application. And Dinesh, thanks for your demo. And everyone, stay safe. Have a great remainder of your day, and we'll talk some point in the future. Bye all.